I'll go ahead and call the hearing to order, and ranking member is going to be, she's delayed for just a little bit. But we also have a vote coming up at any moment, which will delay the hearing slightly, which I apologize for that. We never know for sure when they're going to schedule votes, and unfortunately they're going to schedule right in the middle of our hearing. But we'll go ahead and get started and see how far we can get before they do call that vote. 3D printing or additive manufacturing is a process of creating objects from a digital model, typically through the deposit of material layered upon layer until an object is formed. And today, we're here to discuss just how 3D printing is spurring innovation and entrepreneurship all across the country. While the technology has been around since the 1980s, it has traditionally been used by large companies in industrial settings for rapid prototyping. But in the last 10 years, 3D printers have become more affordable, which is opening the door for smaller businesses and entrepreneurs to begin benefiting from this, from the technology. For instance, some models are now available for under $1,500, and analysts expect prices to continue to go down. Small businesses and entrepreneurs are using 3D printing in a variety of ways. It has the ability to save time and cost during the creation of prototypes, make highly accurate parts that assist in product production, and produce finished products that may be sold directly to end users. 3D printing has become and will increasingly be a critical component of the operations of many small businesses. While a number of entrepreneurs and at-home innovators are using it to print models of products that they intend to manufacture with traditional methods, others are using the technology to create products from start to finish. Sometimes, that can be done right there in the garage. As 3D printers continue to become more affordable and advanced, the number of small businesses that begin as household manufacturers is likely to skyrocket. While some embrace and capitalize on new technologies, others are very wary and cautious about the technology. As Congress and other regulatory bodies consider policies applicable to this and other technological advances, it is important that we must not be hasty and do not unduly restrict the ability of small businesses, entrepreneurs, and other innovators to help grow our economy. We're fortunate to have with us a very interesting group of makers and users of the technology, which includes entrepreneurs that use 3D printing in their development of products. And I look forward to hearing from your insights on how small businesses are using this technology to grow and obviously create jobs, which is what this committee is all about. So we'll move right on into our witnesses. Our first witness today is Patrick O'Neill, who's the founder and CEO of, is it Olloclip? Olloclip, a clip-on lens for iPhones and other Apple products. Prior to founding Olloclip, he was product manager and VP of product development at Premier Systems, which is an information technology reseller and consulting organization. Mr. O'Neill was named Entrepreneur Magazine's 2013 Entrepreneur of the Year. Welcome to the committee, and look forward to hearing your testimony.
Chairman Graves, Ranking Member Velasquez, and members of the committee, I am Patrick O'Neill, CEO and founder of Olloclip, the mobile photography company. I invented the Olloclip, a clip-on lens for the iPhone. I'm very grateful for the opportunity to speak with you regarding our use of 3D printing and how it has helped a small business go from a kitchen startup 3 years ago to selling a product in every Apple store worldwide. I've spent my whole career in the technology industry. I hold over 30 patents, and 3D printing has enabled us to innovate at a rapid pace. This pace is required for us to be at the forefront of mobile technology as well as keep jobs in America. In creating the Olloclip, I wanted to create a photo lens that would give people the ability to use the iPhone to capture photos artistically, creatively, and spontaneously. The Olloclip design was inspired by the philosophies of Steve Jobs, founder of Apple, and Colin Chapman, the English founder of Lotus Cars, for clean, simple designs. Since the start, we employed this simple and light design philosophy. At the beginning, when the design studio was in my kitchen, we used a local 3D printing company to produce hundreds of prototypes. I would ask myself, would Steve Jobs think this product was good enough? The answer would invariably be no, and we would keep refining until we felt the result would meet Steve's demanding standards. After a year of development, we launched the Olloclip through the Kickstarter crowdfunding platform in May 2011. Olloclip received funding within 4 weeks from backers in more than 50 countries and achieved almost 5 times of our funding goal. Since our start 3 years ago, we've moved 3 times to larger offices and now employ more than 50 people in Huntington Beach, California, including 7 full-time designers. Today, Olloclip is considered the leader in mobile photography products. Olloclip products are now sold in more than 90 countries. The Olloclip has attracted a legion of passionate users and received numerous awards. I was also fortunate enough, as you mentioned, to be named Entrepreneur of the Year by Entrepreneur Magazine. 3D printing enabled me to innovate quickly and turn my idea into a commercial product. Design and 3D printing are still the core of our development. In just the past 6 months, we created 6 new products to enhance our line of photography tools, thanks in part to 3D printing. We've invested more than $50,000 in 3D printing to prototype our own products. We also print models of rumored devices, so lenses can be designed quickly each time Apple releases a new version. We sketch an idea in the morning, model it in the afternoon, send it to the 3D printer, and have a prototype that evening. Fast turnaround is key for companies in this space. We finished and validated an iPhone 5 version within days of the device's announcement. I can't imagine doing this without our own 3D printer. Here's the process of developing our products. We first start with brainstorming and concept generation, then sketch ideas and create CAD models of those ideas in the computer, then print the models on the 3D printer. Next, we evaluate the prototype for functionality, proportions, and aesthetics. Changes are made if needed and reprinted. If the prototype is approved and everything looks good, we move forward to mass production. The mobile device market changes so quickly. To stay competitive, we use the 3D printer every day to develop new ideas. We've found that it's the best way to innovate quickly and get to market faster. We can now develop products in a week or two. Without 3D printing, it could take months for development. As Apple launches products, we would miss critical launch timing and market opportunities. This could result in a potential loss of millions of dollars of sales, perhaps even failure. Small and mid-sized companies like ours need the ability to compete on the world stage, especially in rapidly changing, innovation-driven industries like consumer technology. As 3D printing evolves, we would like to use it for bridge manufacturing to produce finished products so we can get to market even faster. At Olloclip, we continue to think differently and are not afraid to try new things. We only build products if we can innovate. 3D printing allows us to take more risks because it shrinks the opportunity cost. We're able to test and validate new designs within a day or two, rather than a month or two. If they're unsuccessful, we can quickly move on to try something else. Our successes come from our passion and perseverance, our ability to take risks and blaze new trails when it comes to product innovation. As Congress and others consider policies that will apply to 3D printing, it will be important to ensure entrepreneurs like myself are able to continue using the technology in innovative ways. I'm honored to be here today. Many thanks to Chairman Graves, Ranking Member Velasquez, and this committee.
Thanks, Mr. O'Neill. Our next witness is Jonathan Cobb, who's the Executive Vice President of Public Affairs for Stratasys, a global leading manufacturer of 3D printers. Mr. Cobb has served in several positions at Stratasys, including Executive Vice President of Global Government Relations and Global Marketing, and he served as the company's spokesperson. He's also held the position of Vice President and General Manager for the Dimension 3D printing business unit of Stratasys. Today he's testifying on behalf of the National Association of Manufacturers. Welcome to the committee.
Thank you. Chairman Graves, Ranking Member Velasquez, and committee members, thank you for the opportunity to tell you about 3D printing and how our company Stratasys is helping small businesses grow and thrive in this economy. My name is Jonathan Cobb, and I'm Executive Vice President for Stratasys, which is based in Eden Prairie, Minnesota. Stratasys is a member of the National Association of Manufacturers, and I'm honored to testify on behalf of the organization. As the nation's largest manufacturing trade association, the NAM represents 12,000 small and large manufacturers in every industrial sector in every state. Manufacturers are the world's leading innovators and perform 2/3 of all private sector R&D in the nation, producing more innovative breakthroughs than any other sector. I'm proud to say that 3D printing and Stratasys are part of this innovative American industry. You may be asking, what is 3D printing and why should I care about it? Simply put, 3D printing is a process of turning digital blueprints into tangible objects within a matter of hours. It works by sending digital schematics to the printer, which then shapes very thin layers of plastic, metal, or other materials into physical objects. I brought a couple samples that hopefully we could talk about a little bit later on if there's some questions. Although the concept may be new to many of you here today, this technology has existed for decades. 3D printers were originally created to help engineers test designs before spending money on expensive factory tooling for production. Today, 3D printers are not only just used to make prototypes, they are also used for low-volume manufacturing, items such as prosthetic limbs and interior components of aircrafts. 3D printing is also found in the classroom. In fact, since 2002, nearly 1/4 of Stratus's business has been in education. By helping students learn design and manufacturing through 3D technology, we're helping build a strong hiring pool for businesses in America. This brings up an important point. 3D printing will not replace traditional manufacturing process. It will serve as another tool in a toolbox for manufacturers to deliver products to markets in efficient and customized ways. Stratus was started in 1988 and has been growing ever since. In 2005, we started a separate business unit called Redeye, which is a service that can produce 3D printed parts for those who don't own a 3D printer. We also acquired Solidscape of Merrimack, New Hampshire, which helps jewelry designers and dental markets adopt 3D solutions. Last year, we merged with Brooklyn-based MakerBot, a 3D printing company whose user-friendly products are designed for prosumers and entrepreneurs with basic technical skills. The growth of our business has helped others as well. When magician Chris Miles was performing at events with his band, he used a popular credit card reader to process payments when he sold his CDs. The credit card reader plugged into his laptop, but he found that the reader tended to swivel or spin when it used, instead of remaining stable. That made it sometimes difficult to use. Borrowing from his children's Lego pieces, Chris built an accessory that kept the card stable. With a successful design, Chris wanted to bring his new innovation to market. It would have been costly and inefficient using traditional production methods. So instead, Chris had invested in a consumer-level 3D printer, which has literally become a factory in his desk, enabling him to produce his invention from home for a couple thousands of dollars and sell thousands of them. We take pride in stories like this. To us, they demonstrate that we are not just a business of producing 3D printing machines, we are also helping empower entrepreneurs by bringing manufacturing into their homes and workspaces. Our presence here today shows that the interest in 3D printing is strong and the future is infinite. Our industry is experiencing rapid growth and is giving domestic manufacturing a new competitive edge in this global economy. The best thing Washington can do is to encourage further growth and investment. As President Obama noted in his recent speech touting 3D printing hubs, if we want to attract more good manufacturing jobs to America, we have to make sure that we're on the cutting edge. Our company could not agree more. I'd like to thank the committee for holding this hearing, and I'd be happy to answer any questions that you have.
Thank you, Mr. Cobb. Our next witness is Peter, is it Y.J. Marshausen? Y. Marshausen, founder and CEO of Shapeways, the world's leading 3D printing marketplace and community. Prior to Shapeways, Peter was the Chief Technology Officer at Sangen, which he and his team designed and developed satellite broadcast modems. He's also Director of Engineering at Ermiska, where he's responsible for delivering a business broadband service via satellite. He was born and raised in the Netherlands and moved to New York in 2010. Thanks for being here.
Well, good afternoon, Mr. Chairman and members of the committee. My name is Peter Wijmershausen. I'm CEO and co-founder of Shapeways. I'm honored to be here today to discuss how 3D printing is fueling small business growth, enabling anyone to create a business with physical products at low capital cost. As a kid in the Netherlands, I loved coding and playing with computers, resulting in a passion for open source software. Driven by this and my entrepreneurial spirit, I spent much of my earlier career at various software startup companies. One of these was Blender, the first company to publish a free 3D modeling software. This turned out to be important. In 2006, much later, I learned about the technology called 3D printing, which prints physical objects based on 3D computer designs. I immediately thought of the Blender community, a large group of 3D modeling enthusiasts. They, like other designers, were using 3D software, but never imagined it would be possible to hold their own designs in their hands. So I asked some of them for their designs to print, and when I showed the 3D printed products to them, they were completely blown away. They immediately agreed it was a good idea to build an online service where people could print their 3D designs, and I knew there could be a business opportunity. How big was yet to be seen. I started working at Shapeways in March 2007 within the lifestyle incubator of Philips Electronics, who shared the vision that 3D printing could be very disruptive. At the time, 3D printing was used mostly for prototyping by large companies and was very expensive. By 2008, we launched Shapeways.com to enable anyone to make and get products they want. We started 3D printing products, not prototypes. In 2010, we spun Shapeways off as an independent company and moved our headquarters to New York City. New York is perfect for Shapeways, providing us with high-caliber, tech-savvy talent who are hungry for innovative solutions. It's also the creative epicenter, so we have the ability to talk to so many of our customers and learn from them firsthand. At that point, we had fewer than 20 employees. Today, we have over 140 in New York, Seattle, and in our factories in Eindhoven and Long Island City. These factories are transforming old industrial hubs into factories of the future with new and innovative processes and machinery. Shapeways is now the world's leading marketplace and community to make, buy, and sell custom 3D printed products, unlocking design opportunities for entrepreneurs and creative consumers. Shapeways itself is already a success story in terms of small business growing out of endless possibilities of 3D printing, but the opportunities created by 3D printing for entrepreneurs are immeasurable. When I think about what we can achieve, I relate to how the internet has enabled software engineers to become entrepreneurs. Before the internet became mainstream, bringing new software to market was extremely difficult. You had to know what users wanted, build the software, test it, then produce a lot of CD-ROMs or floppy disks, bring it to retail, and hope that people would buy it. Today, using the internet, any software engineer can become an entrepreneur. The internet has removed the barriers. Launching a website has become incredibly easy, and this is one of the reasons why companies like Google, Amazon, or Facebook became successful so quickly. Similar to how the internet removes barriers for software development, 3D printing is removing barriers for manufacturing products. Designers can create their products, have them printed with little cost, ideate and update their designs quickly so there is no need for marketing research in advance, build products without costly upfront payments for manufacturing or molds, and distribute their products directly online with no retail investment. Plus, they can continuously evolve their products since they don't have to keep any inventory. And there is no question that entrepreneurs are taking notice. From 2012 to 2013, product uploads increased from 40,000 per month to 100,000 a month. And the number of new people creating products on Shapeways has doubled. 3D printing transforms how we think about launching products, enables the garage entrepreneur in ways we could never conceive of in the past. To understand this in detail, let me quickly share with you how Shapeways works. Anyone can upload a 3D design to Shapeways.com. There are many free and open source software programs available to use 3D modeling to literally anyone literally anyone can do it. After the design is uploaded, the user selects the material on which to print and make it available. Shapeways offers over 40 materials and finishes, including precious metal, bronze, ceramic, plastic, and full-color sandstone. Designs are reviewed by our engineers. They're then uploaded to our printers, and then they're printed, after which they are cleaned by the engineers, sorted, and put in the boxes and sent to anyone. On-demand 3D printing, as described above, is at the core of Shapeways. People have used to create endless types of products for their hobby or business, including model trains, jewelry, funny internet memes, home decor such as lamps, dishware, cups, plates, etc. I've brought a few samples that you can see over here. Let me share one of the examples of a successful business on Shapeways. Gotham Smith is an example. 4 friends who were working in the creative industries in New York City wanted to create something more tangible and lasting than a website or app. Starting with designing cufflinks and eventually moving into other jewelry, Gotham used 3D modeling applications to develop unique ideas. Shapeways gives them the ability to quickly turn those ideas into physical prototypes and then finally products at scale, without relying on large and costly metal casting machinery. They sell their products on Shapeways.com directly and through other channels, and are emphatic that their business wouldn't exist without Shapeways or 3D printing. The ability to easily create one-of-a-kind customizable products is another phenomenon spurred by 3D printing. An otherwise extremely costly and labor-intensive process, 3D printing and Shapeways make it seamless. One company that is leveraging the technology is called Nervous Systems, a design studio that uses a novel process creating custom simulations inspired to natural phenomena such as the growth of coral. Their process generates products such as jewelry and light fixtures. All of these products are one-of-a-kind and 3D printed by Shapeways, sold on our site and multiple retail channels, including the MoMA store in New York. They are one another example of a successful business that is rapidly growing and employing more people every day as demand grows. I'd like to conclude with the fact that even the President of the United States has acknowledged that this great opportunity Shapeways is currently working on. Shapeways is working with the White House to partner on the first ever White House Maker Fair, dedicated to showcasing and celebrating the maker movement. The goal is to support the culture of making and use it as a call to action for stakeholders, and Shapeways has committed to help the White House use this moment in time to facilitate entrepreneurship. And in the State of the Union last month, President Obama spoke about the facility in Ohio, saying that a once-shuttered warehouse is now a state-of-the-art lab where new workers are mastering 3D printing, and which has the potential to revolutionize the way we make almost everything. It's true, 3D printing does have the potential to revolutionize the way we make everything. I'm passionate about helping others see that, and I hope that I have effectively demonstrated to you the positive impact I can have on small business, creating many jobs in the process. Moving forward, it will be critical that the accessibility to 3D printing remains uninhibited. Thank you for your time today and allowing me the honor to speaking about 3D printing, a technology that I'm sure will change the world.
Thank you, Peter. Our next witness today is Jan Baum, who's the director of 3D Maryland, which has been charged with bringing the 3D printing and rapid technology agenda to the greater Baltimore region. Ms. Baum is also a full professor at Towson University and the founder of the university's Object Lab, a comprehensive state-of-the-art rapid technologies and digital fabrication lab. In 2012, Ms. Baum co-hosted the first Rapid Tech and Additive Manufacturing Conference in the greater Baltimore region, and in 2013 was named an Innovator of the Year by the Maryland Daily Record. Ms. Baum, thanks for being here.
Chairman Graves, Ranking Member Velasquez, and committee members, I'm honored to have the opportunity to speak with you about technologies that are significantly impacting how we carry out our work across industries. From product development and manufacturing to skull surgery and bioengineering, 3D printing gives us new capabilities that alter how we compete in an increasingly global marketplace. I'd like to start with a real-world example. So I'm the executive director of 3D Maryland, a statewide leadership initiative to advance the engagement and implementation of 3D printing and additive manufacturing as an innovative economic driver for Maryland, but also for America. 3D Maryland is located within the Maryland Center for Entrepreneurship, which is a business incubator in Howard County, Maryland. Within 2 weeks of a new client joining the Maryland Center for Entrepreneurship, he sought me out and he said, "I hear you're the 3D printing person." And I said, "I am." And he started telling me about his product that he was innovating and wanting to prototype, and how he had sent $2,500 to China and hadn't heard anything, and could I help? And I said, "Well, when do you need your prototype?" And he said, "Yesterday." And I said, "Well, send me the 2D drawings and I'll see what I can do." He promptly did, and I immediately turned them around, had the 3D digital files made, and 2 days later, hopeful, he knocked on my door to check the progress. I'm sure not expecting what he found. He's put his head in my door, in the door, and I pointed to the build platform on the 3D printer across my office. He looked at his prototype sitting on the build platform, looked at me, looked back at the printer, looked at me, speechless. And I said, "That's your prototype." And he looked at the printer and looked back at me, and he said, "This is like magic." Well, it's not magic, but it is a tool that helps us do our work better, more efficiently, locally, and many times, most times, faster with optimized solutions across industries, whatever work it is we're carrying out. 3D printing and additive manufacturing is a disruptive 21st century technology. It's changing the who, how, when, why, and importantly, the what of what we make and how we solve problems. If we can imagine it and we've got the skill to design it, the 3D printers will print it. We are making things we could have never made before. And there's tons of examples on the table here today. It's disrupting economies of scale, current business models, and democratizing production across industries. Innovation and entrepreneurial opportunities are at the heart of this technology. There are some barriers to engagement: access to knowledge, both trusted knowledge sources, and understanding what the technology can and can't do. Overcoming industrial era thinking is a huge one. We have made things subtractively for a very long time, and we're very good at it. Cost of entry, the allocation of resources, whether capital or human, is a challenge for small businesses and entrepreneurs. And then the position of the technology, are we there yet, is a question that we all receive regularly. 3D Maryland, the leadership of Howard County in Maryland, County Executive Ken Allman, the Howard County Economic Development Authority CEO Larry Tweel, and the Executive Director of the Maryland Center for Entrepreneurship are a very strong leadership team for Howard County. And they very easily saw the vision and the opportunity that these technologies brought and how it fit in with and supported small business and the entrepreneurial ecosystem. 3D Maryland itself is an innovative and entrepreneurial initiative addressing barriers to entry and advancing the business advantages of 3D printing for business, industry, and entrepreneurs. Those are our target audiences. We are raising awareness and facilitating engagement and implementation. 3D Maryland is identifying and addressing opportunities to strengthen and advance the rapid tech ecosystem in Maryland. And we're building a loosely coupled system of collaborative relationships and partnerships across sectors to innovate and accelerate the region and the country's economic competitiveness. I respectfully recommend that this committee encourage and support initiatives such as 3D Maryland that have a focus on multi-sector, cross-disciplinary, pre-competitive collaboration, building on the strengths and core competencies to advance current practices, foster innovation, and grow regional ecosystems while taking advantage of public funding sources. Supporting initiatives like 3D Maryland builds on the momentum created by recent initiatives such as the National Additive Manufacturing Innovation Institute. Addressing and creating an adaptive workforce at all points on the spectrum is also critical to our engagement of these technologies. I would recommend working at the grassroots level, locally, with users with proven track records from both industry and education. So we can institute some changes in K through 16, vocational training and apprenticeship programs, retraining programs, et cetera. Wider adoption is inevitable. We need to ensure that the workforce is prepared to increase engagement. Studies have shown that students who are educated in additive manufacturing processes are among the first to bring the advanced hands-on technologies to their employers. And that's something that I've told my students at Towson University since I established that lab. You are workforce leaders. Continuing to support research, funding, and programs that facilitate technology transfer, 3D printing and additive manufacturing are just getting started. I thank you very much for your attention and your consideration of these technologies.
Thank you very much, and we will recess just until after this series of votes. How many on there? 3. And then we'll come back and start with questions. So, committee's in recess. We'll go ahead and call the hearing back to order, and we'll start questions with Mr. Lukemeyer.
Thank you, Mr. Chairman, and thank all of the panelists for a very impressive testimony. It's interesting stuff. I know on the way over to votes a while ago, I was talking to Mr. Bentivolio here, who's got some experience in your field, and it's fascinating to talk about the possibilities and what all you're doing. So it's as a small business guy, it's very rewarding to see the entrepreneurial aspect of this and see that folks are really doing some good stuff. One of the concerns that I have is, getting startups like what you do, and because it's a rather new product, a new process from the standpoint of not widely used, I guess. Are there regulatory problems that we need to be aware of here in Congress that we need to put a stop to, or are there ways that we can enhance your ability to do your job better? You can just go down the line, and whoever's got some comments or concerns about. Everybody's got concerns about Washington these days, trust me, and rightly so. Mr. O'Neill, you want to start? You got any problems with us? There is a
I do not yet have any problems with you.
Not yet. Key word yet, right? Well, obviously the healthcare law is something that concerns a lot of small business people, and you're at that 50, if I recall.
Yes, we are.
So that may be a concern to you. But from the standpoint of producing your products, that's the kind of regulations I'm concerned about right now.
I figure if we just keep working hard, designing great products, and making money, everything else will figure it out.
So far, you guys are so far ahead of regulations that you've outrun them. So therefore, you probably are okay for a while until somebody figures out, well, we need to stop these guys and regulate them. So we got to make sure that doesn't happen.
No, I don't want that to happen. I mean, our feet haven't hit the ground. We shipped our first order to Apple out of our house less than 3 years ago. And, now we keep moving. We've got 17,500 square foot facility now, and that's not big enough. We need to go get a bigger one. So I understand that there are some complications, and I let other people in our business worry about those things. That's probably why I don't seem concerned. I'm sure I should be, but
you hire people to worry for you, right?
I really do, because I don't like to worry.
I understand. Mr. Cobb.
Thanks. Go back to the beginning of Stratasys, which has really started, like I said, in '88. We've shipped about 50% of our business overseas, and we continue to do that at this point in time. It's been a big piece of our business. So, if you look at areas that we're concerned about or could be concerned about, would be any export laws that would restrict this technology from from moving out from the U.S. I mean, if you look at the bulk of our business, we manufacture in New Hampshire, we manufacture in New York, and we manufacture in Minnesota. And so all these products are being exported. So anything that would harm that export.
At this point, there is no problem in that area. That's not a barrier yet.
It's not a barrier yet, but I know there's been some discussion about that. So just since I had the opportunity to address the question, yes.
Flag stuff here so that we can be watchful for that. I mean, that's the purpose of the hearing today, to make sure that we know those things ahead of time.
Yep.
Mr. Marshington, I'm sorry.
Well, we are not really concerned about things that are currently in place, but there might be something that you could help with or think of. Shapeways has a large community of designers that make their own ideas come to life using our platform. They upload them to our site, and then they have them printed, and we ship it back to them. And the other element that is to Shapeways is that we enable people to open shops where they can start selling these products, and I brought a few that you can see right in front of me. Now, if some of these products currently infringe copyrights, which very rarely, but it does happen, then the DMCA gives a very nice process where the copyright holder can send us a notice. We take down the product from our website, and the story or the discussion then is between the copyright holder and the person that is allegedly the infringer. And that process scales very well. You have to realize we have 400,000 community members, and that is growing very quickly. We get 100,000 new designs every month. So these numbers are really large. And DMCA helps with the copyright end of the spectrum. However, there is no such process for patents. So if someone would infringe a patent, there is no clear process akin to the DMCA that would enable the patent holder to notify us so we can take it down. And then the discussion becomes between the copyright or the patent infringer and the patent holder. In that case, platforms like Shapeways are party to the discussion, which of course is really hard for us because we get so many new designs that it's completely impossible for us to check. Also given the fact that in most cases we only print things only once, it's for us completely impossible to check whether there are patent infringements going on at the time. So of course we're open to build compelling technology to help solve this, but since the DMCA works so well for copyrights, I would suggest maybe think about having a similar type process for platforms like Shapeways, and there is others coming up as well in the United States and also abroad, to have such a process that can help these platforms stay scalable and flexible.
Do you have disclosure statements that you have to sign whenever you are sent a drawing of some kind by an individual or a company that says if you produce this object that you are restricted from showing it to anybody else or anything like that?
So the idea about Shapeways, since it's a community, is openness. However, our terms and conditions do ask people, do you own the copyright? Do you own the rights to use this product and upload it to Shapeways for one? Do you have the rights to have it manufactured for yourself? And do you have the rights, if you want to sell it to others? And people have to state that they have those rights, of course. However, some people might not read that.
Very good. My time is up. Otherwise, I'd let Ms. Baum answer. Thank you.
Mr. Bentivolio.
Thank you, Mr. Chairman. Thank you for coming in. Yes, we had an interesting discussion on the way to votes about the possibilities of 3D printing. And I explained to my colleagues that I was a vocational education teacher as well as general ed and was in the automotive design business for almost 20 years. And I'm very familiar with 3D printing and proud to say that many of my female students went on to Case Western to study biomechanical engineering because of CAD and some of the things they got to make in my classroom using a 3D printer from Ferris State University. At the time, we just sent the design to them. They printed it for like $35. They sent it back in a nice package. Instead of putting something on the refrigerator door, hey, Mom and Dad, look what I did in class, they got to put it on a table, which was kind of interesting. But in that regards, I'm wondering the possibilities. We're looking at some things like, for instance, one of my questions is, if I could scan something, can I, digitize that and have it made, right? So, for instance, hip replacements, that kind of thing, could I use an X-ray data and convert it to digital and then have a custom-made hip for a patient if I was a doctor? And there's some regulations that would have to come with that too, right? I mean, it has to be sterile, made from a specific material. So we could do that with bone as well. As if somebody crushed a bone, we could replace that using a 3D printer. And how long would that take? For instance, I'm not a doctor, so I couldn't even name a bone in my wrist, but
Both of those examples are current practice today. So most of that, to my understanding, most of that work is being done abroad in Germany and Sweden. ArtCam is one of the OEMs in Sweden who is producing hip replacements. And right now, while we can take the personalized data from a CT scan or an MRI scan, and we can digitize that, we can build that into a three-dimensional model. My understanding is right now what we're doing is creating those hip replacements in a small, medium, large, 3 or 4 sizes, because that does the job and does the job most effectively. And there are, I may not remember the name of the university that is doing the bone planting. I think it's in Texas, that are growing bone structures. But biomedical engineering is huge, yeah. Yeah, and I mean, what I would say is I would share with you that at Johns Hopkins University, there's a skull surgeon there by the name of Dr. Amir Dorfshar, and he uses 3D printing to create 3D prints to do pre-op planning. And so they know before the team ever goes into the operating room exactly what the cuts are, what's removed, where the staples are. Everything is done in order to simplify that process. I think that's fantastic. The doctor's working less hours in a stressful situation, the patient's under anesthesia less time, and the operating room costs are a huge contributor to healthcare costs, and that's lower. This is disruptive technology. Now, that's upsetting. That's going to upset the apple cart in many directions. So the business model for hospitals is now going to be disrupted. They may not be so happy about operating room times being declined, because now they have to go back and rework the numbers again. But healthcare, medical is one of the first industries to engage 3D printing and additive manufacturing.
great. So we can actually, for instance, if there was somebody that needed plastic surgery, a plastic surgeon could use the X-rays and know where his cuts are going to be, know how he's going to repair this patient's face, if
Absolutely.
you will.
And they also use 3D printing for surgical guides. So they put the 3D print right on the patient's body, and then they know the tool, they know the cut, they know the angle. It takes a lot of the guesswork out. And I would just also volunteer that in terms of what 3D Maryland is doing, one of our first initiatives or first activities was to create an expert user group. So to gather all the expert users in Maryland around these technologies and cross-pollinate them. And so the Applied Physics Lab is actually collaborating with Dr. Dorfshar to build robotics to make that surgery even better, to make it even smoother. We're also printing cells. So, and I'm not sure, again, like who the doctor is that's doing this printing skin, but they're printing skin during surgery from the patient itself. And when you print cells from a patient, you really limit the risk of rejection or the body rejecting whatever you're putting in it or on it.
Okay, so now we have that, and it also reduces 3D printing prototype build time, correct? No longer are we doing the giant clay models. We can actually design parts, for instance, for a motorcycle. I could design everything on that motorcycle using a 3D printer, put it together, make sure it all fits, and probably reduce my build time and prototype costs to, do you have any numbers?
Well, when I see the case studies roll through, and John can probably speak to this even more clearly, but when I see the case studies roll through and I go, okay, what am I going to present like a baseline? I think many times it's at least a third or a fifth of both the cost savings and the time savings. And then the other thing too is, like, you have those savings, but when you put those parts together and they're not quite right, you're not going back to square one. You're tweaking.
So how long would it take, real quickly, how long would it take for me, for instance, once I have that information digitized in and I'm going to do the surgery, to have maybe a model that I can practice or look at? How long would that take to have that prototype or the 3D print?
Really wild. Those are hard questions because you don't know how much data, what the scale is, and scale is a factor. I would say, so if I'm thinking about Dr. Dorfshar's skulls, and he uses SLA technology, I think those skulls probably take 3 or 4 hours.
3 or 4 hours.
Maybe 6 hours. And what I'm advocating for Maryland, and I think it's a model that we could all look at, is that Maryland create a consortium project-based model where we have state-of-the-art medical facilities so that Dr. Dorfshar can see a patient from shock trauma and then zip files right over to a local center and get them. We don't have to worry about FedEx anymore. And then we'll start to really see improvements in the technology as well.
And I started in the business, Mr. Chairman, when we took a body side molding on a car, sent it to the shop, and waited 3 months to get a prototype model, and now we can get it done in a matter of hours, right? Thank you very much. I really appreciate you being here. I yield back, Mr. Chairman.
Oh, thank you, Mr. Chairman. I'm sorry I missed the opening part. I was caught up in another hearing, but thank you all for coming. So I may well be asking questions you answered, and if that's the case, I apologize. But I'll go back. I have a little experience in 3D. We've been using that for 5 or 6 years in one of my companies to make small-scale models of fairly complex machinery as part of our sales proposal. You know, if it's a $6 million proposal, it's well worth delivering that, and maybe others are going to catch up, but early on we were the only one doing it, and there was a wow factor there. And then when we got the order, everyone in the customer's company wanted another one. So it is great. It's great for a lot of things. We use it as a sales tool. I guess my question comes to, as this takes off, are there any quality control issues on repeatability and, you know, all the things you do in ISO and other quality things for repeatability and, you know, CNC machines and whatever? I'm a machine shop guy. Are there quality control issues? And once you get into production and out of prototyping, and I'm not sure who to ask, so if somebody wants to jump in.
So since we're building hundreds of thousands of products on a yearly basis, and actually over 100,000 a month now at Shapeways for our customers, we see these kind of problems pop up. We make, for instance, very popular iPhone cases, and of course for them to fit, and to make clear, Shapeways doesn't provide prototyping only. We print final products. My iPhone case that I use myself is 3D printed, and many other people buy from Shapeways just to get a unique iPhone case. But they need to be exact fit. And since 3D printing was used for a long time as a prototyping technology, there is definitely need for the technology to improve from a quality perspective, from a price, and even from a speed perspective to meet the needs of today's consumers. From a prototyping perspective, you always have somewhat of an option to, if the prototype doesn't come out right, to do it again. But if you have a consumer who has a birthday party where he needs to bring a present, you have only one shot to get it right, get it out the door in time. So the technology has come a long way, and it's really great that we can make final products using 3D printing and enable so many people. But I think the technology is still, to my opinion, in its infancy, and it will keep growing as the big consumer market engages. There will be large jumps in how the technology will mature.
So, you know, as you're layering this, you know, plastics, I understand, I'm sure powdered metals are probably being used, some ceramics.
Yep.
Is that the place, and what happens when you get into the need for some really high alloy steels, stainless steels, et cetera? Is that like way out, or is that never?
We're printing in metals already in several types. We print in silver, which is the same type quality that you would find in a jewelry store. We print in ceramics. We print in stainless steel, brass, bronze. We're adding other precious metals pretty soon. It's already possible.
Carbon steel too?
Not yet.
Okay. Is that coming, you believe?
Yeah.
Okay. So as this takes off, what is the thought on the cost? You know, today you've got a lot of machines running unattended. Labor cost is all but zero. You set a machine up, and they just pop those out even in a dark factory. Is this similar, or what would be the labor cost to make a part using 3D versus automated equipment today in a factory that the machine just does it without manpower?
Sure. Yeah, I think you look at where 3D printing is being utilized today, and was mentioned before, it is being utilized in a manufacturing environment. Aerospace company, automotive companies, a number of people are using 3D printing today. So I think where it makes sense is not the things that we're maybe thinking about, where you're making tens of millions of bottle caps or something like that. But where it makes sense at this point in time is when you have a short production type of a run, or maybe a custom run, or maybe something where, because of regulations or other reasons, the part is constantly changing. And so when you look at the cost of a piece part, the piece part cost that you're going to get utilizing 3D printing is going to be more than, say, injection molding. However, you're not going to have to build that tool. So as a small business owner, a couple cases that were mentioned here today, you're not going to have that upfront cost. So you're also probably not going to have that upfront knowledge as well, because you can design something, you can test it with a prototype, and then start printing that as your real part. So it's a little bit different as far as high volume versus mid to low volume, I believe.
Thank you very much. My time's expired, so I yield back.
Mr. Payne?
Thank you, Mr. Chairman. And I'd like to thank the panel for their testimony today. But, with the rapid growth and accessibility of 3D printing, there's room for great innovation, as it's been stated. As many of you testified, 3D printing creates endless opportunities for entrepreneurs. However, with companies like MakerBot increasingly reducing the cost to own and operate 3D printers, do you feel eventually consumers will become their own manufacturers, making their services many small businesses offer obsolete?
Certainly MakerBot and products like that really enable a lot of people to do work as far as design work, and then some production type of work that we were talking about. And I think for certain products, yeah, you could see where a product like MakerBot would actually be used in a home environment. I think, though, that where some of the big opportunities for 3D printing comes in is really in the manufacturing process. As we talked about before, it allows current manufacturers to build things in a different manner, to customize things in a different way. So I think there's certainly some products that, yeah, are absolutely geared toward that. But if you look at the use of 3D printing and all the different materials that are going on today, I think the bigger advances are going to come in the manufacturing area. And with that becomes a whole area where students today, or people that are in the workplace today, are used to manufacturing in traditional methods. And so training of people that are currently employed, or training of students to design utilizing 3D printing is one thing, but then to manufacture using 3D printing is vastly different. It's different than injection molding, but it can be used, in fact, and that's one of the big inhibitors, I think, in getting 3D printing into small and medium-sized companies, is because the characteristics of a 3D printer are different than the characteristics of injection molding, for instance.
And on another note, I serve on Homeland Security as well, and the potential of creating weapons through this 3D printing. What is the feasibility, the possibility, and someone coming along and creating a non-detectable firearm or something?
Well, we've been staunch supporters of the plastic gun legislation that just got reenacted, I think, at the end of last year, as a matter of fact. So it's something that has been demonstrated at some point, but we've certainly been a supporter of the legislation that's taken place up to this point, looking at the restrictions on that opportunity.
Okay, but could someone potentially not follow the guidelines and regulations for this type of product and create something that's not detectable and cause a problem?
I'm not an expert in it, but I think that you need some type of metal, either a bullet or the firing mechanism for the firearm. So again, I'm not an expert on that, but from what I know, I think it would be difficult.
Okay. Thank you.
Schweikert.
Thank you, Mr. Chairman. It always makes me nervous when a technology like this is here in Congress because it means we're paying attention to you. And let's face it, when the bureaucracy pays attention to a technology, we often try to regulate it or screw it up. And I say this in the context of someone that believes one of the great successes of the Internet was the fact that it grew and grew and grew before sort of the bureaucratic mechanisms truly understood it and were able to slow down the investments, the capital, the creativity. So what is, for whether it be 3D printing or even the thing that maybe you and I haven't even found out to define yet, which may be the large scale or the high-speed production of such, what's the systemic threat to the industry? Is it copyright? Is it the source files having patent litigation or copyright litigation chasing? Or is it those of us in government and the bureaucracy? I mean, if I came to you right now and said, over the next decade, this is one of the great disruptive technologies that's going to make us a more efficient society, but we have to conquer these risks to that expansion. For each of you, and we'll start with Mr. O'Neill, what would you say, what are the systemic risks to the technology?
Well, I'm an entrepreneur, so I'm not representing the manufacturers. We use the technology to create innovation in our own business. So, you know, these kind of questions don't really apply to us. But I would sincerely hope that no legislation comes in that would restrict our ability to do that.
What about the discussion that I know we've all been running in and out, so I haven't heard copyright?
Well, copyright is a concern to us as a copyright holder. And as a holder of 30 patents, I'm concerned that people will infringe our patents and our designs, and they'll print them. And we've had that happen. I mean, we had that happen with Shapeways, but we worked with them, and they were able to deal with it. But it's a concern. I mean, it seems like, you know, it's something that needs to be addressed, but I'm not sure it's a 3D printing specific concern, because it's still IP is IP, whether it's 3D printed or it's made in some other way. And we have people in China that are making counterfeit products all the time of ours, and they're not doing that with 3D printing. They're doing it with traditional manufacturing.
Well, and Mr. Cobb, sort of the same. What's the systemic risk? And on IP, I think there's been the discussion of saying, well, if I change just a bit of the source code, does that relieve me of a copyright? So.
Well, I guess as a manufacturer, you know, the laws in this country, you have the patent protection. As you know, from a manufacturer, what we do is we spend 10 to 12% of our overall revenue on trying to be more innovative, trying to stay ahead of things that are going to fall out as far as a patent goes. I think looking at, you talked about what can be an inhibitor. I think one of the things, and maybe it's a little bit off base here, but I think one of the things that will not help the industry as much as possible is young people and traditional workers not being educated in this technology. And I think there's a real opportunity at this point in time to have education at a high school level, at a grade school level, and then even workers that are displaced because of manufacturing. I think manufacturing is starting to come back into the U.S., and I think 3D printing is a portion of that. And I think there's a real opportunity for the federal government to get more involved in training of new students and traditional workforce.
But do understand, as we get involved, there's also certain risk profiles that come with that.
Understand.
What would be a systemic risk to your business?
Well, I already laid it out briefly, is that, you know, and as you mentioned, we want to, you know, Shapeways is a platform, a service. So what we want to do is create as many products for people as they like and make it possible for them to create things that weren't possible before. In that way, democratizing how people think about products. I mean, everybody can now make things instead of only big companies. But we are taking very serious the responsibility that we need to take, that we can only make things that are original. And the good thing is, you know, Shapeways has made over 2.5 million products to date. That the amount of products that we had to take down, the amount of products that we actually made using the printers, that were infringing in hindsight were extremely small, like in counting on one hand or two hands, less than 10, that we actually made. And that's, I think, the good thing, because people grasp that they now can make anything they want. It's not the first inclination. Actually, the technology is much more expensive also than mass manufacturing, so it's much easier to copy something popular with traditional manufacturing technologies, as mentioned in China perhaps, then you can do it on a 3D printer. But this, yeah.
And forgive me, because I know I'm up against time, but academia has always an interesting world where it sits there, where what's sort of in the public domain, what is, so you may have to navigate some more interesting discussion there.
Well, I guess what I would, my response to the question is, it may bridge academia, it may not. And so I come from, I'm an advocate of the technology for business, industry, and entrepreneurs. And what I hear from my expert users is one of the things that is going to hold the industry back, or is holding the industry back, is the proprietariness of both the hardware and the materials. So I think the expert users that I see using the technology in the most advanced way say to the OEMs, I don't care about your warranty, I want under the hood. And they will hire a third-party contractor that provides the warranty, so that then they can put in any material they want, and they can tweak the parameters. If you don't do that, then you are paying about $25,000 per set of parameters to be under the hood. And so, and I know Peter agrees with me, keeping the technology open, just like your example, your leading example of the internet, we've got to keep it open. The U.S. is not a leader in this technology. I think the Western world is leading it, but...
Ian, I know I'm way over time, so real quick. The code, the underlying code, proprietary to each manufacturer, or sort of a common script?
Proprietary, how the parameters that you run the machine on and the materials that you put into the machine.
So if I were to hop online right now and want to start design and actually do some coding.
Yeah.
And please, then I'm a decade old, out of date SQL programmer. So
I'm going to let John jump in on that one.
Well, I think if I understand your question correctly, the capability of sending a file.
Well, how proprietary is the software for each manufacturer?
Okay, now so the software to actually allow you to print a part.
Correct.
Okay, so I'll answer it in two ways. The software that allows you to have access to the printer is common. It's called an STL file. Okay, and that's common to all the different companies that are out there. Then what's proprietary would be actually how the printer prints. Each one of them uses a variety of different technologies and parameters, so that would be proprietary, if that answers your question.
Thank you. And Mr. Chairman, thank you for your patience with me. Thank you.
Could each of you, you all brought a variety of things, starting with Mr. O'Neill, can you kind of tell us about what you've got in front of you, or show it off?
Sure. Well, as I said before, when we have to bring products to market very quickly, because the iPhone refreshes every year, and it usually refreshes around September or October. So to get the products into the stores for the holiday season, we have to be very quick. So whenever there's rumors on the internet, we'll take those rumors and take the specification, actually print a copy of an iPhone, a 3D one based on the rumors. And then we'll print a product that would hold our lenses, a clip, that, to see how it fits, see how well it works, and evaluate whether we're happy with that. And we'll keep working on this all through all the rumors. Every time there's a new rumor, we'll do a new one, and we'll do hundreds of designs of the product to get it right. So then when Apple actually does release the phone, then we've got this product that we can put on there, and we can test our lenses on the new device. We can test the fit and see how it is. And then if we're happy with everything, we send it out to manufacturing and have tooling made so we can do injection molding. And then we're in production, and that whole process takes about 6 to 8 weeks.
Mr. Cobb?
A little bit picking up on what Patrick was talking about, but this particular part was a part that really gets to that idea of taking a prototype into a realistic area. What we've done is utilized a printing process somewhat similar to an inkjet printer, but it gives you really the realism that you get from a part, and that's what a manufacturer or designer is looking for. In the particular process that we're using here, called PolyJet, what it allows to do is mix materials. So you have something very durable. It's called a digital ABS, the white part, but at the same time, you're printing this flexible material here as well. This was printed all as one part. Okay? Then just recently, we introduced the capability of the multiple material, and then we've also added color to that. So you can actually then print a very realistic, in this case it's a prototype shoe, but a very realistic prototype shoe that to most people coming in here looking at this, you'd probably think it was the real thing. And then getting towards the idea of real things, this particular part is a different technology that we have called FDM, or fused deposition modeling. This particular technology takes real thermoplastic, so nylon, polycarbonates, and ABS, and Ultem, that are being used today in manufacturing, typically an injection molded process. But in this particular case, this is an ABS part that we're seeing here. This was printed, again, there's about 18 different components here. This was all printed in one particular piece. Okay? So from a prototyping standpoint, it allows you to look at a lot of different things that are going on, because it's not just an individual part, it's an assembly. And this particular prototyping technology allows you to look at those assemblies, testing for form, fit, and function. And then as you go a little bit further, you can also, because it's real thermoplastics, these are the types of materials that are being used in real life today for end-use parts in aerospace, automotive, some consumer goods.
Well, I brought a variety of products. It's so hard to choose if there's so many people creatively active. So in my testimony, I used an example of a design collective from New York called Gotham Smith. They make men's jewelry, and these are cufflinks that are made in sterling silver, designed by them, and they're for sale on our platform, and they also sell it in a different way. So that's one example. Another that is really cool is an indie game. So it's just almost organic movement, crowdfunded, the Kerbal Space Program. They made a little game and a very passionate community behind it. And a few guys figured out, hey, can we take our assets from the game and turn them into real things? So they uploaded it to Shapeways, and it was working. So now this is, people ordered them, took pictures, went on the internet, went viral, and everybody now wants to have them. Two very different examples. I mentioned nervous systems. They use algorithms, so they don't even design the products anymore by hand. There is no CAD software involved. They write computer code that mimics nature. And by doing that, they can create unique items all the time. This is an example of a light shade with an LED light inside. And you can go on their website, you can go on Shapeways, you can find these products, and they're for sale. And Ms. Baum has actually brought another product from Nervous Systems, which is a customizable necklace. And this is also from Nervous Systems. So you can see that it's a wide variety, from jewelry to lighting fixtures to gadgets and game accessories. And I can keep going for hours, but I won't.
Right now, I'm wishing I had selected my samples a little bit differently, and so I had some skulls sitting up here and the face transplant model that Dr. Rodriguez did a year ago. The other thing that I wish I had brought is an example of 3D printing with with traditional metal plating over top of it. And so one of the companies in Maryland, Repliform, they plate specifically on 3D printed objects, extending the life of the plastic prints. And some of the work that they do is highly classified, but what's in the Knowledge Center at 3D Maryland is a 1/10 scale thruster that they made for Boeing, and those objects are really impressive. What I have in front of me are some soles, some prototype soles from Under Armour. Under Armour is an anchor business for Baltimore for sure. That's probably as much as I'm able to say. I'm close friends with Under Armour and frequently behind the door with them. But so right now they're prototyping soles. This is a watch, and this is off of one of Mr. Cobb's systems, and this is the same idea of the gear shifter, so a very flexible material and very rigid material at the same time. This is an end-use product from Northrop Grumman, which is also located in Maryland, and this is an end-use part. So prototyping end-use parts, and this is a metal printed part that then had some post-production machining done on it. And then I guess I would just tag on with Peter about this little guy. This particular printer prints in full color. And when we talk about entrepreneurs and we talk about the uses of the technology, if you take a 3D photograph of yourself or maybe your daughter or your grandchildren, and you want to have that replicated into a doll, your kids can have dolls that look like them if that's what you want to do. Mickey Labs is doing that in the UK. Stanley Black & Decker, also located in Maryland, uses this to color code the parts of their tools as they put it through a production. So orange is one division, green is another division, or they code the parts accordingly. And that's not an extra, that's just inherent to the technology. And the last sample that I have is, that I'll talk about is this architectural model. And anyone who, we're all probably old enough to understand that architectural models before 3D printing were made very painstakingly with X-Acto knives and mapboard. And today we can actually we can print the prototype of the building. And there's a saying in the industry that if a picture is worth 1,000 words, a prototype is worth 1,000 pictures. And I think as our society gets more and more visual, our literacy maybe declines a little bit, but we become more and more visual. That's more and more true. And then lastly, in my testimony, I included a really nice profile of a company in Baltimore by the name of Denko Arlington, and it's a traditional foundry. It's a wonderful American story. 94-year-old family-owned business, 3 or 4 generations, and they started losing their pattern makers, and they said, "What are we, how are we going to solve this problem?" They don't want to see this successful business change, and so they adopted 3D printing in 2010. They have a number of Stratasys machines, the highest end machine that Stratasys makes, and they say that they win bids because they send a prototype of the object that they are going to create for the defense industry with the bid, and that's how they get successful bids.
You all bring up an interesting point, too. In terms of your different mediums that you print with, how does that translate into durability or strength or whatever the case may be? I'll let any one of you answer that want to.
I'm going to point the finger to Mr. Cobb because he's got the highest end materials.
The bulk of our business is in the thermoplastic area, and I talked about the nylons and polycarbonates, ABS. And traditional manufacturing would be utilizing an injection molding process to bring those parts. We don't quite do that. We don't melt it and we don't put pressure into it. We actually use the layer technology that we all talked about in the past. And so the characteristics of that are different than the traditional injection molding. Now, we are using real ABS, real nylon, and real polycarbonate. There's a wide variety of manufacturers around the world. We just select one of those. So the difference is not in the material itself, but the difference is in the way the part is actually manufactured. And so when I was talking a little bit earlier, we talked about having the knowledge from a designer, the knowledge from a tool maker, and the knowledge from a manufacturer to understand that a 3D printed part is, in our case, a real thermoplastic, but it's made differently than the traditional injection molding. Injection molding has been around for a long period of time. There's a handbook that really talks about injection molding, the principles to make sure that you build a durable part. There's no such thing for 3D printing or additive manufacturing today. And as the technology evolves, new materials evolve, and they're evolving every single day. Having that knowledge to understand the differences between an injection molded part, in the case of a thermoplastic, and a 3D printed part is going to be important in producing more and more parts for end users, because they can be used utilizing 3D printing. They are being used in 3D printing today, but it's a different design criteria, it's a different manufacturing method, and it's different.
Can you take, let's say you don't have a drawing, or you don't have you're doing it just in the restoration industry, out of curiosity. Can you take an existing or wore out part and create data points and then turn around and reproduce that? So fairly, and how expensive is this for somebody to, like if they employ or call somebody, they obviously don't want to buy the technology themselves, they just as soon have somebody do it for them. How expensive is it to create that part as a model to be able to fit up?
So you can use scanning technologies that are getting more and more powerful today. We actually were just at South by Southwest where we were scanning people at parties, which was a big party hit. And in the same way, you can take a part, and if it's still in one piece, you could scan it. Not all parts can be scanned, however. You need to be able to see all items of it. It's going to be very hard to scan this part Mr. Cope brought with him. But, more simple products you could very easily scan. And those scanners are getting very affordable. They turn the pictures basically they take into a model you can print, and then you can print it in a wide variety of materials. To your point of questions around what does it cost, well, the scanners are available from a few $100s up to like tens of thousands if you want to have high-end professional stuff. The printing itself, again, depending on the material you want to use, items the size of an iPhone case would cost you $20, $30. Things that are getting a bit bigger, they're $50 to $100 in plastics. If you talk about metals, objects the size of this are around $100 to $200. But this is like real stainless steel. So, you can make things in silver, all kinds of materials based on scans if you wanted to for repairing stuff. And it's been done.
So you can build up in metal?
Sorry?
You can build up in metal?
Yes, metals are possible, just like ceramics and plastics, yeah.
It's fascinating. With that, I want to thank you all for participating today. And again, I apologize for the vote series that happened during the your hearing, but your testimony has obviously helped us to better understand how 3D printing is spurring economic growth and creating a lot of opportunities out there for entrepreneurs around the nation. With that, I'd ask unanimous consent that all members have 5 legislative days to submit statements supporting materials for the record. Seeing none, that is so ordered. And with that objection, I would say hearing's adjourned.